Thank you, PrimeKey, for having me. Hello, everyone. So we're going to have a lot of slides today, so I hope you can bear with me. And I'm Canadian, so I'm going to apologize just in advance. Pardon me, sorry. 10 minutes extra. All right, great, excellent. So we're going to go over quite a few of the requirements, the differences. I'll get to that in a moment. So I'm here to talk about the wonderful thing that is FIPS 140-2. So try to contain your excitement. So what we'll start with is exactly how old is this thing? Can you believe it's 18 years old? There's been some minor updates, but it's old enough to drive. It's old enough to vote. It's old enough to go to college or university, depending on where you're from. So it's pretty old. So you can imagine there's some problems, and we'll start talking about that, and we'll talk about maybe some of the problems that the new standard at least aims to resolve. Not much has changed since 2001, right? We're still using these on a regular basis, just kind of furthers that point. So my objectives for this talk is to provide you, well, a very, very high level, very, very brief history of this crazy FIPS thing. We're going to do an overview of the cryptographic module validations under CMVP. There's going to be a bit of the tale of the two FIPS the 2-3 successors that were out there at one time. Then we'll walk through the ISO-based FIPS 140-3, which will be used under CMVP. We'll be discussing some of the differences, some of the new terms, some of the differences. And then importantly, these last points is where I really want to spend some time too, is on some of the key dates for the transition. What will happen to your existing FIPS 140-2 certificates. That's very important as well because you have customers and partners that rely on those. And then our advice and recommendations on how to survive the transition. A tiny little bit about Acumen Security. So I am the FIPS lab manager at Acumen Security. We've been doing this for quite a long time, myself and my colleagues. We're based in Maryland in the US. We also have an office in Mumbai, India. We are an accredited security testing lab and common criteria testing lab under NIAP. We do a bunch of different product security and product certification services. Won't go into too much of that. Acumen was acquired by Intertek, which is from the UK, in 2017. We also have a sister lab in Ottawa, Canada, and we were fortunate enough to partner with our friends PrimeKey on their FIPS validation. So Admir, I hope it wasn't too painful, but yeah, exactly. I think it's Orest who had the gray hair. So what is this FIPS thing? I won't spend too much time. I'm going to assume everyone has some familiarity with FIPS 140-2, but it's a US government standard for federal information protection, and it's the security requirements for cryptographic modules. The -2 means it's the second iteration, and right now, the federal governments in the US and Canada mandate the use of cryptographic modules. So in the federal government, if they have a system or product that's doing crypto, it needs to have a FIPS certification. And it's for the protection of sensitive but unclassified information, or SBU. Anything that's at the classified level, there's a different program for that. Why is it important? Many of you might scoff in the audience, but it's kind of been established as the default benchmark for security products that do crypto. Again, it's the minimum bar for some of these whitelisting programs in the finance sector, in the healthcare, legal, and utilities. FISMA, FedRAMP, Common Criteria, HIPAA, High-Tech, they all require FIPS 140-2 certification. The NIST controls catalog also requires FIPS. And the one thing I like to say that even though we make fun of that it's a bit deprecated and it's perceived as being fairly esoteric as well, like just few people with this knowledge, it really is important, and really people do need it. Our customers, they do need it to sell in some cases. Their partners need it. So it really is important to them. And it's not necessarily fun, but it is a business enabler. I apologize if you can't read all of this part, but I wanted to try to put this whole time capsule into one slide. And so I found online actually some of the PDFs of these old documents, so I thought it was pretty cool. I guess I'm a nerd. But 1982 Fed standard 1027. It was mostly just DES line encryptors, but they actually have the standard online still published, and so that's a snapshot of it. 1991 is when we got FIPS 140, and you can see there is a bulletin from NIST actually in April of 1991. So again, you can see a lot of this stuff is fairly dated. FIPS 140-1 was in 1994. And that's when we started to get a little more flexibility. We had a DTR, so those are the derived testing requirements that actually had some desired outcomes for the test cases. Then we went to 2001, where FIPS 140-2 was published. And that manual, one of my colleagues actually has it, believe it or not, from when they did the workshop for FIPS 140-2. We looked at more software, some software requirements in FIPS 140-2. There was an IG. It was approximately 65 pages at that time. And then we got a change notice in 2002, and in effect, that's really the FIPS standard itself has remained the same since then. There's been an IG, which I'll talk about in a couple of minutes. There is a DTR, which has gone through a couple of revisions, but the standard has been cast in stone due to US bureaucracy mostly. Who is the CMVP? They're the cryptographic module validation program, and they're responsible for the administration and the oversight of the program. I interface with them quite often. They're folks at NIST, and on the Canadian side, CCCS, which is the Canadians Cyber Center for Cybersecurity. Pardon me, they've just recently changed it for the third time, so I'm still having trouble with that acronym. So Acumen Security is an independent third-party accredited laboratory, and so a part of NIST, NVLab, accredits these labs to do the testing on their behalf, and Acumen Security is one of those. I think there's about 23 in the world right now of these labs, and we do the functional testing, or we do the test cases and the source code review of the crypto modules on their behalf. We submit a report. What they do is review our report, ask some questions, and then they ultimately determine if you get your FIPS cert or not. This is one of the differentiators. There are other nationally sponsored programs, but they require, in many cases, source code from the vendors, and as many of you in the crowd know, that could be a non-starter. And so that's one of the things that I think, at least, why CMVP has been taken up as kind of a de facto internationally. The government don't see your source code. There are challenges with FIPS 140-2. I'm sure many of you have made a joke or heard a joke or read a blog. So I'm not going to stand up here as a truther, not a FIPS truther. Definitely recognize there are challenges. In fact, my job is many times to deal with those challenges, and I'll get to that in a couple of moments. But as you can see, FIPS has gotten a bit of a reputation for being inflexible, potentially even challenging for many software validations. My customer feedback hotline, self-tests, sometimes questionable value, sometimes real value, but sometimes in not all applications or implementations, they have a lot of value when you're running all those self-tests at power up. Some examples is a continuous random number generator test on a software PRNG or something like to that effect, running posts on each instantiation of a library. A post is a power on self-test. A lot of vendors today are frustrated that we can't do validations, quote unquote, in the cloud, when that would be so in Azure or AWS or Google Cloud. And there's some limitations in the standard, in the scripture, on platform requirements. And you have to specify the exact hardware you're testing on. And as many of you know, that's a little challenging with, you can't go up and kick the box when you're testing on an AWS instance, as an example. Many of my customers have, from time to time, maybe not arrest, but have complained that you need a sledgehammer for the air handling capability. There's really no agility or flexibility at all. It's very rigored, and there's zero flexibility. And then it's, again, like I mentioned, it's esoteric. I won't say the second part, but there's a lot of lore, FIPS lore. And it's actually led to some good niche business, I think, for some consultants. You really do need you to guide you down the interpretive path sometimes, and so that is one of the challenges that the standard has and may continue to have. if pardon my pronunciation on these, but Skohorn. So this has really become what I do, or what my team does for a living. Is on a day-to-day basis, we're shoehorning, we're putting square pegs in round holes, we're finding the best way to validate software modules or systems on a chip or virtual HSMs, or where just the standard 18 years ago was written for like a single-purpose hardware module. So that's really has become our job, and we have to think out of the box. We have to have a very pragmatic view and interpretation, and of course we want to de-risk that by making sure the scheme is on board with it, but we have to get a little creative. And here's an example of an ARM processor. There's so many things going on. There's so many different, you can have different IP blocks doing different things. There's so many different layers of complexity. They're all doing crypto. How the heck do you take this through FIPS 140-2, right? I've had to do it. And so there's just so many things. It's very challenging, is I guess what I'm trying to say. How has the CMVP dealt with time? And silver tape. Did I get that okay? I don't know. Yeah, thank you. So what's happened is, I mentioned earlier that IG document grew from about 67 pages. I just checked last week, it's 250 now. So we're up to 250 pages, and it's not a fun read. It's not something you want to just sit down and go from start to finish. The end isn't satisfying. There's many shalls and shall nots, and that means new requirements. That means, in effect, the IG is implementing new requirements. So this duct tape comes with new requirements. And for many years, one of the challenges with the older regime at CMVP is they did a lot of this in isolation. They did a lot of this without outside feedback from a lot of these industry, like if it's IETF or ISO, they didn't get a lot of feedback. And so in that ivory tower, you start publishing requirements that don't make sense. And you don't really find that out, that you kind of have that echo chamber until the labs start testing, and then the vendors start really thrashing against some of these requirements that just don't make sense. And that was some of those blogs were the reason, or I shouldn't say the reason, were as a result of some of this echo chamber thinking. And again, when you're publishing guidance after you've run into an issue, you're reactive, right? So you're never going to be solving these problems. You're not going to be agile. It's going to be slow. It's going to be painful for everyone. And that's one of the challenges that the program has, is they publish an IG months after they've come across the issue. AES GCM is a good example. What took so long? Again, the text might be slightly hard to read, I'm not sure, but I'm going to go through this pretty quickly because I don't want to spend too much time on this, but I do think it's kind of interesting, at least to, again, me being a nerd. So NIST actually announced the intention to go forward with FIPS 140-3 in 2005. They had a full plan. They actually solicited public comments. They had a workshop, and then they went to work on putting a standard together. In parallel, there was a group at the CMVP, which led to a bit of a fracturing later on in the relationship, but there was a group that actually sat down with ISO and did the first version in 2006 of the 19790, which is, of course, the successor for 140-3 that we'll be talking about later. And so this included some CMVP members. The other draft, which I'll refer to as the 2007 draft, got first published in 2007. And it was a NIST-developed document, and so this is a little bit of opinion, but again, it still had some of that ivory tower thinking, and it didn't quite take into account some feedback from international organizations. It did go out again for public comments, and they took over a year to collect and review the comments that they received. In 2009, they had the second draft they tried to integrate some of the feedback, some of the comments, and they had the second draft of this other standard. And then subsequently in 2010, when the public comment period ended, they had over 295 pages of comments. So that was a lot, right? That's a lot of comments, and they were stuck. So you see here, 2012, they still hadn't addressed the comments. NIST publicly came out and said, we got to go back to the drawing board here. There's just no agreement. There's no consensus. And if that comments document, you can actually go and do a Google search, and you can find that comments document. Some of them are not very kind. It's a oof. interesting document. So FIPS 140-3, was it becoming vaporware? It really was at one point. It was becoming a butt of a lot of jokes. There was a philosophical split at NIST, like I mentioned. Again, this is a bit of an opinion, so please don't, well, I guess it's going to be on YouTube, right? But, oops. They got bogged down. There was a bit of a disagreement on direction. There was talk of actually FIPS 140-4, so just skipping that draft altogether and moving to FIPS 140-4. So as you can see, there was just a lot of thrashing. There was just a lot of challenges. Time passed. It became, like I said, the butt of a lot of jokes. Even with us, we were calling it different things. We were teasing the scheme about it if it was ever going to come. And then more time passed. So what led us to the holdup, what led us to the ISO-based -3? And again, some opinion here, so pardon me with that opinion. The whole time that the -3 was getting all those comments and thrashing and having so many challenges, the ISO kept chugging along. It was going through different revisions. In 2008, in 2012, and again in 2015. And it also had sort of that international consensus and input. And the version of the DTR came out in 2008, and then again it was updated in 2014. So getting a little bit of traction, getting a little bit of momentum, and here's where my opinion comes in. I think at around the same time, 2014, something happened with a particular algorithm. I don't know if, can anybody? Just yell it out if you know it. No? Uh-oh. Martin. You're right, dual ECR, a DRBG. So I don't know if everyone's familiar about that one, but so what happened there is due to maybe a little bit of the way NIST was publishing documents, they had to do a formal review of sort of their entire process, and it changed as a result. What resulted was a 75-page document or so that mandated them to have a bit of a strategic change of direction. They were going to need to go through public comments. They were going to need to engage the international community more. They were going to not be able to sort of do things in isolation without some checks and balances. And so I think, again, this led to the ISO becoming the natural successor, so 19790. And in fact, at that time, it was actually becoming, it had a lot of the concepts of the draft 140-3 anyways. If you speak to some of the scheme members, they said there was maybe only a difference of 3 to 4 pages of actual requirement differences. So the two were fairly close. Okay, so we decided on ISO. Now what's the holdup? Well, rod tape and bureaucracy. Oh, I'm sorry. I failed. So we all agreed that the ISO was going to be the next step. But during this time, there was some personnel changes at CSE, which is the Canadian arm, and NIST, which of course is the American arm. And then there was also government administration changes. And so just priorities got shifted, things got backburnered, nothing got done. It was just bureaucracy and red tape. So we have a new hope, right? Well, at least my team does, because we're kind of sick of the current one that we're working with. March of this year, officially, it was signed off by the US government that the ISO 1970 would be the official successor to FIPS 140-2. There are actually, this is quite timely, this discussion, because next week, the 23rd of September, I believe, NIST will actually be publishing the first drafts of SP 800-140. There's going to be a series of these documents that, in effect, replace the ISO annexes. And that will have all the, some of the NIST requirements, the NIST-specific things that could supplement or alter or augment some of the requirements in the ISO. So next week is a date that I'll definitely be looking and getting those documents, picking them up, and there will be a time to do some public comment on those. I won't spend too much time on these, but there's some other ISO documents that are related to the 1970. One of the important ones is 24759. That is the DTR. I apologize for the color scheme on this one. But there's also some other documents that talk about the testing of the non-evasive attack mitigation techniques and the physical security And we also have some testing techniques for the folks that do the validations. So there's some related ISOs that NIST will probably pick up once the ISOs themselves are done, and then may choose to put those in those annexes. And here's the annexes that I was mentioning. Again, don't want to bore you with these details too much, but they will be pertinent. They talk about the vendor documentation requirements, such as your security policy. They include those approved security functions. As an example, AES would be in the block cipher publication 838A. There's the key generation and key establishment stuff. So 56A for doing key agreement as an example, though that'll be in that particular document. 140 is going to be a bit of a change that I'll get to, but they're going to publish some approved authentication techniques in there. So that'll be different from FIPS 140-2. And then finally, Annex F or 140F is where they're going to talk about the non-evasive attacks and the mitigation test metrics for that. And that'll likely go to that ISO document that I just mentioned. What happens to the IG? One of the things that was good of having the CMVP on the ISO program is they actually baked some of the current IG into FIPS 140-3. Some of the stuff there's new terms that we'll get to in a moment, but that's a good thing. That means the IG, in effect, is going to shrink significantly or go away, more or less. And they're going to be moving some of the programmatic stuff to a web-based manager's manual. And that's more like how the labs need to conduct their business and how they need to interface with the schemes and so on. They're really important, the IG. It can change requirements, it can augment requirements, it can be new requirements. So a lot of folks come to us and their engineers have done a full review of the FIPS 140-2 standard and the DTR. And then we go, well, did you guys look at the IG at all? And they're like, no. And we're like, oh no, we got a lot of work to do because the requirements do get changed by the IG. Some of the new terms that we're going to see in the ISO-based FIPS 140-3. They have a degraded mode of operation, which is different from the FIPS 140-2. And what a degraded mode of operation is if I'm a cryptographic module and I have several algorithms, and one of which fails its power on self-test, or its pre-operational self-test, to use the ISO term, it can still load, it can still continue to load, keeping that algorithm sort of unloaded and remain with other limited functions. So you can still do some other operations and say troubleshoot or do what you need to do if that one component has failed. So that's a good thing. This is a good thing. We have some new terms on how we talk about CSPs and keys. So we have SSPs, which is a sensitive security parameter. We have public security parameters, and what they've taken forward from the FIPS 140-2 standard is CSP. The way I like to think of it is this, that the confidentiality and integrity requirements apply to the SSPs, and for the PSPs, which are public security parameters like certificates and so on, like public certificates, really only your integrity requirements would apply. There's also a trusted channel, which was in FIPS 140-2, but it really was, it hearkened to more common criteria. It brought in a common criteria requirement, and so they've removed that reference, and they've kind of defined it on their own. And again, it's just mostly, pardon me, intended to protect against eavesdropping. I mentioned earlier pre-operational self-tests. So this term is going to, in effect, replace power on self-tests. We also have something called periodic self-tests. And at service level 1, or security level 1, pardon me, it's pretty much the same way it is today. But when you get to service level, or levels 3 and 4, your self-tests have to be done on a specific time period, and you have to actually build in this logic. So that's going to be a change at level 3 and level 4, and it would likely require some coding to obviously make this happen. Conditional fault test. If an algorithm, say your DRBG, during its health checks fails one of those tests, it would need to detect this fault, and then they fail the self-test. It's pretty much the same requirement as today. It's just, I guess, categorized or documented a little differently. We have some new interfaces and some updated interfaces. The first one is the same. They've just changed the terminology a little bit. The second bullet is where they've actually brought in from the IG the terms hybrid for a software and a firmware module. And so in the standard today, there's no definition or concept of hybrid. It's in the IG. And this is an example of where they've baked that in to the new standard. And a hybrid is really just a software with a disjoint hardware. So a software library that runs with a processor or a chip as an example. We also have a control output interface, and these are just provisioning or control commands. As an example, you have a wireless controller and an access point. That controller would, of course, be sending control commands, telling that access point, go up, go down, fix yourself, you know, what have you, giving it a new key or whatnot. We have self-initiated cryptographic output, and what this is, it's basically the module's ability to perform operations or functions without an operator first instructing it. And an example of what I have here is that you have a script or some routine that when your device, your router, your whatever comes up, it's going to establish an IPsec connection right away. You won't require an operator to set that up. Some other new terms, these won't result necessarily in code changes, but in FIPS 140-2, it was extremely deficient in areas where vendors had to do some of their own, say, security testing or having good hygiene as it relates to design assurance. FIPS 140-3 brings in some vendor testing requirements, and so at all levels, you'll have to do something and run some security diagnostic tools such as Coverity or just there's a bunch of them, but you can do some static code analysis and use a report to show the evidence that you're actually doing some due diligence on your code. There's some low-level testing, and what that means is you'll need some written test cases with outcomes for some very specific functionality of the module. It's a bit ambiguous right now, and I'll get to that in a moment, but they don't provide much more context than that, and so we're a bit left to make some assumptions on what they're looking for other than just your typical low-level testing approach, right? So I think vendors may have to kind of make their own assumptions and move forward with that. And last on part of this section is end of life. And so at level 1, you'll have to have a procedure for sanitization of the module. And so what that means is obviously making sure anything sensitive has been zeroized or overwritten or what have you, and making sure that when you dispose of that module, it's being properly done. At level 3 and 4, we actually have to have secure destruction of the module itself and procedures. So you would be telling your end users how to securely destroy the module. Again, a little ambiguous, and so we may have to look at some best practice out there in the industry at first until NIST kind of tell us what's good and what's not so good for this. Pardon me, I skipped that. Now we're going to get into the diff. I apologize. Everyone's going to need a coffee after this, I think, but I'm going to try to go through it as quickly and painless as possible. I do want you to stay awake for the end. I'm going to give you some recommendations on what to do with all this new stuff. So here's just a snapshot of the differences in the sections. You can see there's a software firmware security section, non-invasive security. We have our SSP management, those lifecycle requirements that I discussed, and then those annexes that I mentioned earlier. At 10,000 meters, we're not going to use feet. I'm Canadian, so we're metric too. Conceptually, a lot is the same. They've just, like I said, baked in the IG. They've maybe changed the terminology a little bit. They've maybe updated some of the requirements to deal with more recent technology. They've baked in some of their lessons learned. They are smart people. They get it. They understand there's issues with FIPS 140-2, and so what they've tried to do, there will be still challenges, but what they've tried to do is bake in some of their lessons learned. I've already mentioned it addresses hybrid modules. Okay. Okay. It includes entropy, trusted channel. There's no references to common criteria. I don't know how to do that then in 5 minutes. Okay. We're going to go through this pretty quick. What I'll say is we're doing some blogs. We're doing a series of blogs, and we have a white paper as well on the differences. So I'm going to go through these next ones pretty quickly, just so that I can get to the end where I give you some recommendations. What I would encourage you to do is come talk to me. I can give you the slides. I'm happy to do that. I can point you to our blog where we go through a lot of the differences in extreme detail. We give you our opinion on this stuff. And then at the white paper, when it's available, of course, we can distribute that and send that out to everybody. But at the 10,000 meters, we have some requirements on the delivery and first use. The FSM gets folded into design assurance. And then we also have really prescriptive requirements for the security policy. So David Hook, you think your security policy is really prescriptive now? Wait till you get a load of -3. So I'm going to have to try to skip over some of this stuff because I don't think we're going to have a ton of time, and I want to spend some time on the recommendations. So when we have roles, services, and authentication, the major difference is we have a new service for show version. There's no longer a requirement for a user role. The authentication mechanisms at level 2 actually have to be enforced by the module, so you can no longer just document a procedural requirement for the user when they're doing the setup. There's no defined password metrics at this time. So in FIPS 140-2, there was some kind of silly metrics that they had for password lengths. What you could get away with a 6-character password, in effect. I think that what they will be doing is publishing in 800.140e more modern requirements for the strength of authentication. If you have default authentication data or credentials, obviously on initial use, now they put a requirement in that you got to modify that stuff. You have to change it on first use. At service level 4, you have to do multi-factor authentication. The big takeaway for software, firmware, and OS security is that you can't go beyond level 2 for software, so no level 3. There's some requirements to tap into the operating system if you want to get to level 2, and you have to do role-based access control, identity and authentication, and detailed logging. They've removed the dependency from common criteria. It's no longer acceptable for firmware to just do an EDC. You have to do an approved integrity check. Physical security, most of the differences are at level 3 and level 4. They now have formally described a relationship between the hard coding or potting material and temperature that we use to protect the level 3, say in HSM as an example. There's some testing that they've introduced now, some formal testing for EFP and EFT. And time constraints, I'm not going to go into that today, I'm sorry. The self-tests, we've already talked a little bit about them. There are pre-operational self-tests, and that's a difference in FIPS 140-3, is you only have to run the self-test before you use the algorithm. So today, you have to run your full suite of tests, right? So as an example, if you were to have a library with a dozen crypto functions, you would have to run the cat for all of those. In FIPS 140-3, you can get away with running your integrity test, and then when you need AES, you would run the cat for AES. Or if you don't ever use another algorithm like triple DES as an example, you don't have to run that KAT. They actually have real non-evasive security requirements, and so they actually will have some material testing techniques for the non-evasive attacks. So DPA and SPA, there'll be some real testing for it. We don't have all the details. It's a bit murky right now. We will look to next week when those metrics, that first 140F document comes out. They will have some guidance there. Okay, so I'm going to get to the real important stuff now. I apologize, I'm probably running a little late. So some of the key dates. We have a slide of, slide of order there, I apologize. Some of the important dates for the -3 rollout. September 23rd is that, like I mentioned, next week they're putting out the draft for comment. The 140 series is going to close for public comment on November 23rd. So I would encourage everyone to, if it's important to your business, if it's going to have an impact on you, now's the time. Make a comment. Let them know that either what they're doing it makes sense or it doesn't make sense, or give them some real feedback with a solution from your opinion. If we don't do that, we're going to be stuck. We're going to be stuck with things that we didn't have an opportunity to contribute to. they're going to be gathering program automation requirements, and this is more for the labs like me, because right now our tools really do stink, and we need to get a lot better and automate, and there's a lot of opportunity to fix things that are not currently very efficient, and that process will be from September to December. March 2020, they're going to be publishing those, the final versions of those 140 documents that I mentioned, those 800 series 140 documents. Starting September 22nd, 2020 is when they're opening the door for the FIPS 140-3 submissions. September 22nd, 2022 is when the -2 submissions are no longer accepted. Where can I get this thing? Well, here's a little secret. You can get it for free next week. They're going to open, they have 2,000 licenses. I should get some type of notification, and so please come up and talk to me if you're interested. I can likely get you on a mailing list of some sort. But on their website, there should be an application where you can request a copy on September 23rd, or you can just pay the money if you so choose. Just make sure you get the version, the corrected version, 2015. Our recommendations. Can I achieve a -2 and a -3 at the same time? I would cautiously say yes at level 1 or level 2. Level 3 and level 4, they've introduced a lot of new requirements which are fairly ambiguous, and so with that there's risk. We get far along in the process, and then we have a code change because we misinterpreted something. I have a bit of an analogy that we're kind of, that first little bit, we're going to be in a dark room with some Lego split, all over the floor, and we are going to step on some of those pieces at level 3 and level 4. We do have some new requirements that might be introduced in those 800 140 documents. So we want to look at those. We want to be sure that we understand exactly what the impact of those could be. It might not be practical for anyone, any vendor to start testing until 2020. Yeah, the code changes if we're wrong. Really take a look at your business requirements and evaluate if you really need to be doing -3. I would still, -2 is the devil we know. We know it quite well. We know how to get around all the wrinkles. The -3, we're going to be in a dark room for a little while until we get some reps. What we think you can do today without forking your code is you can implement some of those testing techniques that we discussed using the static code analysis tools. The design assurance requirements, really those are just procedural and documentation requirements. Change the default authentication data, you should be able to do that. You're probably doing that today as part of your procedures. Enforce strong authentication mechanisms. Maybe take a look at like a NIAP protection profile or common criteria protection profile that has explicit authentication requirements or other best practice documents. You could likely if you want to meet -3, if you still do the way that self-tests are required today, you would meet the -3 requirements. So we talked about periodic self-tests. You can still do all your CATs at initial post, and you would meet the -3 requirements. So that was not very efficient, but it would allow you to sort of get a pass on -3. And this is really just dependent on the level and module type. So your experience may differ. The zeroization requirements change. There's bypass requirements. So lastly, or just as I try to wrap this up, I know I'm running a little late, but take a deep breath. -2 certificates are still valid. So for 5 years, and what that means is if you achieve a validation certificate for your module in the 2021 in August, it's going to be valid until 2026. That's a long time in this business, right? And so you really have to talk to your partners, your customers, evaluate your business requirements, and determine, do we really need that flashy, shiny new thing, or is it better to stay with the devil we know and have some longevity and just go and get maybe one more top up at -2 before we embark on putting the resources towards a -3 certification. Some other changes that will affect the program, ACVP, I'm not sure, I don't have a lot of time to go over all the details, but that's going to be completely changing the current algorithm testing process. That's going to be a big impact as well. There's going to be a transition of FIPS 186-2 RSA starting in January of this year. They're not going to be validating FIPS 186-2 anymore for digital signature generation or key generation. That classic CAVS testing, the algorithm testing, is going to go away. And then they'll have the new series of documents that will in effect be the implementation guidance. That's going to be in March. We're going to have new entropy requirements. Our key agreement stuff is going to change. And then I know Mike and David today will be talking about the post-quantum stuff, and NIST has a program for the post-quantum stuff. Unfortunately, I don't think Time AI made the cut for that. But and then 2023 triple DES will be going away. So that's another important one, especially in the European Union. I've already mentioned, if you want to stay in the loop, there's the link for the project site. I'm happy to send these slides out. Join our mailing list. Come talk to me. We're doing a detailed series on the Diff analysis on our blog, and we're also going to be having a white paper later this fall. Or come see me at the ICMC in May 2020. We should have a lot better idea of what's going to be happening by then. I promise I'm done here. The move to -3, it's a good thing. There's still ambiguity, so we need to be a little bit aware of that. We're gonna need to get our reps, both the labs and the scheme. We need to get our reps. We need to go over some of the guidance, make sure we understand the correct interpretations. For now, if it was me, I'd stick with the devil I know, unless you have a significant business reason to try to go be the first that does -3 or what have you. The certs are still valid for 5 years. So if you get a cert tomorrow, it's valid for 5 years for -2. The algorithms themselves aren't going to be affected by the transition. That's in a different document, and it's for a different talk. Make sure you get your copy of the ISO if you want it next week. I can help you with that. And keep an eye on the other stuff. So ACVP, 90B, and the algorithm transitions that are in 131A. And I apologize I went long. Thank you for your patience, and thank you for your time.